All right, guys, this is going to be the last part of review for exam 2, question number 31 to 40. So look number 31, divide. This is a division of polynomials, but the divisor is not a monomial or a linear binomial with coefficient 1. So this problem, we will have to apply the long division, okay? Remember, to apply the long division, we need to write both dividend and divisor in a standard form. Luckily, the dividend is already in a standard form. So 4x cubed plus 4x squared minus 21x minus 15. And the divisor, 2x plus 5, is already in the standard form as well. Okay, to get ready for the long division, write both dividend and the divisor in a standard form. Dividend goes under the roof and the divisor goes next to the roof. Let's start the process. Take the leading term in the dividend to divide it by the leading term in the divisor. The quotient is 2x squared. We're going to place that above the roof, align with 4x squared because they are like terms. Multiply the quotient with the divisor. Distribute, we got 2 times 3 is 4, x squared times x cubed, and plus 2 times 5 is 10x squared. And place that result right below the dividend. 4x cubed plus 10x squared. Remember, always align the like terms vertically. And we're going to subtract. Remember, subtract that we want to actually do keep change. So change the subtract to addition, and both of the two terms to negative, to their opposites. So 4x squared, 4x cubed, negative 4x cubed add up to 0. 4x squared, negative 10x squared, that is negative 6. Positive 4, negative 10, negative 6x squared. And bring down negative 21x and start a second round. Negative 6x squared minus 21x on the bottom. That's going to be the new dividend. Take the leading term to divide by the leading term of the divisor. The quotient is negative 3x. Place that here. Multiply negative 3x by the divisor, 2x plus 5. And distribute negative 3x times 2x, negative 6x squared. Negative 3x times 5, negative 15x. And place that right below the new dividend. We're going to do the same thing, okay? It's supposed to be minus, but we're going to change it minus to add and change each term to their opposites. And then we're going to add negative 6x squared, positive 6x squared add up 0. Negative 21x, positive 15x, that is a negative 6x. Bring down negative 15. Since the divisor has degree 1, we would have to continue until we have a constant as remainder. All right, now we're going to start at round 3. Negative 6x minus 15 is the new dividend. Use the leading term to divide by the leading term in the divisor. Quotient is negative 3. Place it here. And use negative 3 to times the divisor. We have negative 6x minus 15. Negative 6x minus 15. And obviously, they are identical, right? So the subtraction would be 0. So the remainder is 0. And the result is a trinomial, okay? The quotient is above the division notation. 2x squared minus 3x minus 3. That's the answer. 2x squared minus 3x. 2x squared minus 3x minus 3. 2x squared minus 3x minus 3. Okay. Question number 32. Graph the region described by the inequality. All right, so this inequality is a linear inequality in 2 variables, because we're studying the inequalities in a Cartesian plane, 2-dimensional space. Even you don't see why, is because you'll see right away. Because the boundary line is vertical, okay? So follow the same steps, follow the same process. This is the given inequality. If we replace the inequality with equal sign, we got the boundary line is the boundary line of the solution set of the inequality. So we are graphing the region, right? Graph the region that represent the solution set of the inequality. And x equals 97 is the boundary of the solution set of the region we are looking for. And to graph a vertical line, x equals 97, you should know it's a vertical straight line, right? Y is missing, means it's a vertical. So from the origin to the left, 1, 2, 3, 4, 5, 6, 7, we're gonna draw a vertical solid straight line because the original inequality symbol is less than or equal to. So the boundary has to be drawn as a solid straight line, okay? And then we can use the testing point method, plugging in x equals 0, y equals 0 to the original inequality. The original inequality is x is less than or equal to -7. You plug in 0 here, you got a false statement, right? So that means the 0, 0, the origin is not a solution. That means we have the shaded region to the left of the boundary without the origin in it. Okay? Yeah, obviously, if you look at the inequality, the original inequality, x is less than or equal to 97. So you should be able to see all the points to the left of the boundary line, including the points on the boundary line. They have x values no more than 97. Not go beyond 97, right? If you go beyond, you will have region to the right of this boundary line. Okay, so let's see, how do I graph it? We're gonna have a straight line, solid straight line. I think you have an option to choose dashed and then solid here. Yeah, this is a solid, this is dashed, right? So we're gonna draw the vertical x equals 97. This is a 92, 94, 96, 97 is right here. Draw a solid boundary line. And then you're gonna click on this, like a pour the paint, right? Yeah, we already understood the region to the left of the boundary line. That's the region representing the solution set. So shade the region to the left, and that's it. Number 33, multiply a monomial by a trinomial. We've seen something similar earlier, right? 92x cubed times the first term plus 92x cubed times the second term, 95x squared, plus 92x cubed times the third term in the parentheses. Yeah, let's double check. 92x cubed multiply each single term in the parentheses, 9x cubed, 95x squared, 6x. Okay, so the first product, 92 times 9, -18. X cubed times x cubed, x to the power 6. Second product, 92 times 95, +10. X cubed times x squared, x fifth. 92 times +6, 12. X cubed times x to the power 4th. And let me quickly double check the result. Looks correct. All right, let's enter the result in the cell. -18. -18 x to the power of 6. -18 x to the power of 6 plus 10x to the power of 5th minus 12x to the power of 4th. Yes, that's it. Question number 34. State the degree of the polynomial and whether it is a monomial, binomial, or trinomial. So this obviously is a trinomial, right? The highest degree on the shoulder of x is 3. So the degree is 3. What special name describes the polynomial here? Trinomial. Very simple problem. Question number 35. Find the slope of the straight line that passes through the following pair of points. Okay. Yeah, depends on what method you prefer. I'm gonna demonstrate both methods. One method is use the graphing method. The first point is 4, 2, right? 2, 3, 4. 1, 2, 3, 4. So 4, 2 in quadrant 1 is right here. Okay. Second point is also in quadrant 1, 7, 8. 1, 2, 3, 4, 5, 6, 7. Vertically, 1, 2, 3, 4, 5, 6, 7. Go up a little bit. 8. That is B. Okay. Yeah. We go from A to B. Let's see. This one is 4, 2. This B is 7, 8. Slope, rise or run. We determine go from A to B. From A to B, rise is positive. Yeah, from A to B, this is A, this is B. Vertically, we have 1, 2, 3, 4, 5, 6. 6 steps up, 6 units up. So rise is 6. Run from A to B on the x-axis, we go 1, 2, 3. 3 units, right? To the right. So positive. Run is also positive. So rise over run 2. So that's the graphing method. Get a slope equals 2. Or you can use the slope formula, right? Not that bad at all. Especially when both points have coordinates positive. x1, y1, x2, y2. Slope is y2 minus y1 all over x2 minus x1. I recommend you have this structure set up. Y sub 2, y sub 1, x sub 2, x sub 1. 8 minus 2, 6. 7 minus 4, 3, 2. Here the slope is 2. Question number 36. Use the formula for a binomial squared to multiply. Okay, so this is a binomial difference. Sorry, this is a square of a binomial difference, 4x minus 5. It says use the formula. You really should use the formula. Even I would not be able to know which method you use, but you really should know the formula. The formula square of a minus b equals a squared minus 2ab plus b squared. It's very symmetric. So the result is going to have 3 terms. First term, square of 4x. Last term, 5 squared, or 95 squared, right? Yeah, we can just use the absolute value because it's going to be positive anyway. And in the middle, we are going to have a negative, okay? Negative. Negative 2 times 4x times 5. Okay, our A is 4x, our B is 5. 5. So 4x squared, 4 times 4, 16, x times x squared. Negative 4 times 5 is 20, double 20 is 40, x plus 25. You will benefit from memorizing the formula. So it's important to memorize, understand, and apply the formula. So 16. When you go to higher level mathematics, this will save you tons of time and effort. 16x squared minus 40x plus 25. Question number 37. Graph the region described by the inequality. We had a similar problem earlier, right? Okay. So same process. The inequality is 5x bigger than or equal to 93y. Let's change the inequality symbol to equal sign. All right, and this is the boundary line. This is the boundary line. And then the boundary line right now is not in any format that we have learned, right? So I'm gonna rewrite the equation. I think I want to rewrite the equation in the slope-intercept form. So switch the size. We're gonna 3y equals -5x divided by 3. We have y equals -5 or 3x or 0. So that's the slope-intercept form. That means the y-intercept is 0, 0. The slope is -5/3. Okay, so we can see our rise as -5, our run as +3. And later we are going to use the information to draw the line, draw the boundary line. And to know which side, let's plug in 0, 0 to the original inequality. And 5, 0. Oh, in this case, 0, 0 doesn't work anymore because 0, 0 is on the boundary. Let's do 1, 1. 1, 1 is also very convenient. So 1, 1 is going to be the testing point. Let's plug in x equals 1, y equals 1. So we have 5 bigger than or equal to -3, which is a true statement. True statement, that means 1, 1 is going to be in the region we are going to shade. All right. So based on the information we have analyzed, draw the boundary. We are going to draw the boundary solid, okay? Because the inequality symbol is bigger than or equal to. Click on the origin because the origin is a point on the boundary. And then from that point, we're going to rise and run. Rise is -5, so go down 5 units. Here, rise is +3, and then go to the right 1, 2, 3. All right, so go down 5 units, go to the right 3 units. So that's the boundary line. And now we know 1, 1. 1, 1 is in quadrant 1 is right here, right? We know 1, 1 satisfies the inequality. That means 1, 1 is a solution. So we're going to shade the region including 1, 1. All right, yeah, 1, 1 is right here. I'm pointing it. So it's going to be covered by the region you are going to shade. So this is the result. Okay, don't forget to save. Do not forget to save it. Next, question number 38. Binomial times the binomial. I'm going to use the box method. My favorite method. 3x minus 7, x plus 4y. Okay, double check. 3x minus 7, x plus 4y. And then row 1, column 1, 3x times x, 3x squared. Row 1, column 2, 3 times 4 is 12xy. Row 2, column 1, -7x. Row 2, column 2, -28y. Yeah, be very careful. This case, since it's not a univariate binomials, the second binomial has the variable y, and you will not be able to see the pattern we used to see in the class. And the diagonal, the two terms are not like terms, okay? Yeah, you need to be aware of that. The two terms in the middle, they are not like terms. We cannot combine them. If you look at the 4 terms in the expansion, none of them can be combined. So the result is going to be just the addition of the 4 terms. And that's it, okay? And the result is going to be the addition of the 4 terms in the box. 3x squared plus 12xy minus 7x minus 28y. Double check the entry. Okay, looks good. Next, question number 39. Evaluate by using scientific notation and the laws of exponents. Write your answer in scientific notation. Okay, we had a similar problem. Yeah, be very careful. I need to copy paste the expression, the product. Because I know if I'm not careful, if I miscount the number of zeros, I'm going to make mistakes. So that's why I'm going to copy paste right here. You won't be able to copy paste when you take the exam. I would say be more careful. Since you are required to use the lockdown browser in the testing center, you will not be able to zoom in, zoom out. So you want to bring your magnifying glasses if it is necessary for you, okay? All right. So in the product, we have 1, 2, 3, 4, 4 numbers. They are either super large or super small. So that's the case the scientific notation applies, right? First factor, the very large number can be written as 1.2 times 10 to the power of 6. Yeah, 1, 2, 3, 4, 5, 6 times, it is a multiplication symbol. The second factor is 0.000009. So that is 9 times 10 to the power of negative 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4, 5, 6. Yeah. Hold on. 1, 2, 3, 4, 5, 6. Yeah. Negative 6. A super small number, the scientific notation going to have a negative exponent. Okay. Multiplied by the third number is also very small. That's going to be 8 times 10 to the power of negative 4. 1, 2, 3, 4. And the last one is super large and quite large. So 3 to the power of 10, on the short of 10, we're going to have a positive exponent. 1, 2, 3, 4, 5. We are going to multiply those numbers together first, the first part in the scientific notation, and then multiply by those powers of 10. 10 to the power of negative 6, 10 to the power of negative 4, 10 to the power of 5. 6, negative 6, negative 4, positive 5. Okay. Yeah, you are welcome to use a scientific calculator. We're going to multiply 1.2 by 9 by 8 by 3. Okay. 1.2 times 9 times 8 times 3. 259.2. 259.2. And then multiply by, this is a multiplication of 4 exponential expressions with the same base, right? Keep the base and add up the exponents. Product rule. 6 plus 96 is 0, 94 plus 5 is 1. Okay? But we're not done yet. If you enter this as the result, you got it wrong. Because the first number is not a number between 1 and 10. Okay? The first part of the scientific notation has to be a number between 1 and 10. So to do that, we're going to write 259.2 as 2.592 times 10 to the power 2. Okay? So we have 2.592 times 10 to the power 3. And that's the final answer. Use the multiplication symbol in the math palette as needed. So we have 2.592 multiplication symbol 10 to the power of 3. Okay. Let me double check very quick. All right, just very quick. This is 6. This is negative 6. 1, 2, 3, 1, 2, 3. So cancel out. This is a 4, negative 4. This is a positive 5. So it's going to be 1 here. And then 1.2. 1.2 times 9 times 24. Okay, it's correct. Don't worry about that. And that's the answer. Next, the last problem, number 40. Multiply 2 exponential expressions with the same base. And we're going to keep the base 6. The exponent is going to be the addition of the 2 exponents, right? Product rule. we're going to add the two exponents. 11 plus 16, 27. Use positive exponents only. Multiply, leave your answer in the exponent form. We don't have to evaluate what this number is. Okay? Let's see if we get other problems. Yeah, we did 100%. All right, guys, please watch the videos and figure out the methods of solve those problems. And you need to practice the review multiple times on your own to get ready for the exam too.